Hello and welcome to the NeuroTechSF Hack Night for October 28th, 2021. Thanks for joining us. Tonight we will be talking about the Motivate galvanic skin response, and in a slightly more interactive session, I'd like to come up with some experiments that you folks might like to see, because we have the Motivate right here, rocking and rolling. We're streaming data. I have a couple of experiments that I came up with. I have some data that I collected before the call, so we can take a look at all that stuff. One of the things that I was thinking we try is I did try the spicy challenge. That had some interesting results. But for those who remember this torture device, this is the Electro shock game. And it has a pretty interesting way of working. Let's see. Do I still have the on button? Goodness. Oh, yeah. Oh, it works, which is great. I would have been super sad if it didn't. So, yeah, you turn this bad boy on. Enough people remove the controller. I'll be playing just for one tonight. And then, yeah, you hit this button up top. That starts the process. You have a few seconds until the song starts playing, and you have to be the first one to hit the buzzer when the time runs out. If you're not the first one to hit the buzzer, you get a nice electric shock. Now there's two settings that let you control the intensity of the electric shock. And if you're wondering to yourself, hey, is that actually painful? Quite so. You've got this volume slider that kind of lets you know how much fun you're about to have. And then over here, you've got a setting for, do you want, I don't know if that's readable, one shock or three. I have it set to the one shock. I feel like that's going to be sufficient for our testing. And yeah, so we've got that ready to go, and I couldn't be more excited. But if you can think of some other things that you'd like to see demonstrated with galvanic skin response or skin temperature, that's another good one that we might see changes in. I'm happy to do it. So I'll definitely be connecting up the Emotabit, streaming it. We can look at all the data and so on. But yeah, I just wanted to let you know that it's going to be an exciting evening. We have some good data to look at and so on. The next thing I wanted to say is, now that we've actually been collecting some galvanic skin response data, electrodermal activity data, I have to say it's really fascinating. There's some things that I expected to see out of the data that I didn't see. And then there's other things that I didn't expect to see that I did see. Pretty much happens every time we start using a new sensor type. There's usually some preconceptions that we have. Sorry, this is a little too bright. Some preconceptions that we have that went poorly. All right. As to what exactly it's going to show. Goodness. And no, this is terrible. All right, here we go. Take two. What exactly it's going to show, and we're often surprised, because it just turns out that, like, yes, it's going to be roughly what you expect, but the way the data presents is going to be a little bit different. And the other thing, and maybe this just seems like a small thing, but if you ever start self-collecting data, you'll be surprised at how visceral of an experience it is. And I know it's like, okay, whatever. How can collecting data be interesting? Or how can looking at data that you collected on yourself really be that interesting? There's something to it. There's something about looking at it and then being able to understand, like, hey, wait, my experience actually tracks exactly with this data. Like, that's really what I'm experiencing. And then it actually lets you kind of, yeah, understand a little bit about, oh, wait, that's kind of, that's what I'm experiencing, right? Because you can actually sort of start to zero in on which metric is moving along with what aspect of your experience. And so it really is fascinating. As I've collected more and more data using sensors, I've gained sort of a slightly different awareness of my own perception, my own experience, and so on. Because it is interesting. If you've been in a setting where you've kind of understood your biodata, even something as simple as your gaze pattern. Like, if you've never looked at an eye tracker for an extended period of time, I just don't think you'll have the same level of awareness of your own gaze as if you've been in VR or if you've done actual the eye tracking, the gaze bubble. It's sort of like at first it seems irrelevant, and then over time you start to realize, like, by knowing the mechanics of how it is that your body's doing what it's doing, it's sort of like these new things come to mind, like, oh, maybe this would help or whatever. So yeah, this isn't like some big thing, but if anyone ever has a chance to self-collect data, I strongly encourage you to try to do it, even if you're not thinking that you're going to be surprised by what you find, because there is something powerful about collecting your data. There is something powerful about understanding the relationship between the metrics and what you feel. And it is also cool when you start to go, oh, this feeling, this perception, I can back it up with data. So it is actually kind of funny where you go, some experiences I can't prove to people that I'm having, but some experiences I know I can. And it's an interesting thing to like have one of them and go, oh, wow, I could quantify this for people. I could share this with people. And yeah, I was definitely surprised by the sort of impact that has and the way that it guides your experience. Okay, so let's start with the simple stuff. I'm going to... Did my camera just freeze a little? All right, fine. Here is the Emotibit. So I purchased a larger Velcro loop. Now, we have some sensors. Oh, hold on a minute. I will apologize for this, but I need to go get some 3D printed cases from downstairs. They just arrived from Shapeways today. So I think that's kind of cool. We 3D printed the Emotibit case. I'll give you the GitHub links and you'll be able to see it, and then you can see what the finished case looks like. All right, so bear with me just a moment. I'll be right back and hopefully have those cases to show. I can only imagine how good that audio sounds because I unmuted first. All right, so thanks for bearing with me. Here are the Shapeways cases. I printed the Emotibit case in 2 different materials. The first one is the it's the cheaper one. It's the one where like it's the 3D printed inkjet style, but this is basically the case. So it latches together like this, and then it covers the Emotibit from above. So here's the Emotibit, here's the case. They fit together. I'm not trying to mess with it just yet. But yeah, basically this looks good. The material feels nice. this would be comfortable on the skin. We tried to do 2 different smooth plastics. So this is the one with the glass beads. It's like a slight upgrade, but they smooth out the surface. We didn't want it to be abrasive. If someone was wearing this on their wrist, it should feel pleasant to have on your skin instead of like something annoying. And I can tell you this feels perfectly fine. It just feels like a comfortable piece of plastic that's on your wrist. It doesn't cause any issues, doesn't feel uncomfortable in any way. This is the premium plastic. This is a little more expensive, a little more flexible, and you can choose some colors. We weren't sure which one would be better. I do think that this is like a higher quality material, or at least the premium. This is 3 times the cost. So, you know, to give you an idea, each of these pieces was like $12. So this whole case is $24. I think each of these pieces was $30. So this case is like $60 for these 2. But I think for our user research, you know, if it's already a $450 device, you know, may as well add $60 to the cost and you have a nice case that you can even color code if you want to have different units with different cases and so on. So yeah, it was a really nice Shapeways experience. Now we did get the warning message that it wasn't going to print properly. So we had to select the print it anyways thing, and then they give you a big scary message like, hey, if it comes broken, don't blame us, don't ask for returns, etc. But yeah, that warning was much more serious than the issue turned out to be, because I guess once they set your expectations nice and low, they tried printing it and it worked fine. So yeah, I mean, it's good that they have a method of identifying potential prints that are going to have an issue, but just because they indicate that a print is not going to work doesn't mean that a print is not going to work. And so, you know, obviously you're gambling with your money, but it's nice to know that, you know, at the start of the process, I was basically like wondering, okay, is this, if you get the warning, does it mean it's guaranteed to be broken and you're just kind of, you're doing it to yourself? Or are they just giving you sort of a broad warning that the model has characteristics that could be a problem? And to me, it seems like it's a little more of the latter, where, you know, so I'm happy that that's the case, because if it had actually just been broken, like, all right, well, that's a bummer. But this worked out great. So I think we're really happy with it. There's nothing wrong with this $22 case, and it feels great. It's just that it's a little less flexible material. So I could see that these hinges could potentially break. I'm not saying it's like flimsy or anything. I mean, clearly it works. Clearly you can attach it, detach it. But I could just see this going before the other one. And so I think that we would do this just for likely robustness and so on. But yeah, premium plastic works great. Case works great. So yeah, Shapeways came through, and then it's nice once you printed a design and you see it works, and you can order more designs and get it in there. Okay, so we've got the Emotivit case, and let's fire up the oscilloscope and the broadcaster, and we're going to put this on. Oh, and by the way, Rashi, thanks so much for joining us. Rashi did some really cool empirical mode decomposition analysis on the spicy data that we collected. Rashi, I'm not sure if you're comfortable sharing that, or maybe if you just wanted, oh, I'm sorry, empirical dynamical. I think it was the EDM analysis that threw me off, because I was thinking electronic music the whole time. But yes, no, that's the wrong one. Empirical dynamical analysis, EDA. So if you'd like to share the EDA stuff, that would be super awesome. And if you prefer, you can just send me whatever images you want me to cover, and I can. Empirical dynamic mapping. Okay. Excellent. So yes, if you would, whether you would like to send me some images that I can share, or if you would like to, okay, cool. Great. I will show them as well. Download those real quick. All right. Okay, so I'm going to go ahead and download these. It's just going to take a moment. Okay, so I've got those images downloaded. Let's take a look at the downloads folder. Okay, great. Excellent. All right, let me go ahead and share my desktop, and then let's see if we can find. Okay, great. So let's start with this is the. Now, Rashi, you'll have to help me a little bit here because I'm going to misspeak on some of these. But this is the overall plot showing the correlation of the signal versus time. So I believe that you felt that this plot established very clearly that the change in signal was driven by the administration of the spicy food, and that this was true across all the electrodes. And the next image shows that there's no correlation in the opposite, which I think was just sort of a demonstration to see whether it would apply both ways or whether it would work one way and not the other. So in this case, it works when you say, is the spicy driving the electrodes, the brain signals, but it doesn't come out if you say, are the brain signals driving the spiciness, which is sort of a null test, but yeah, we saw it. So this is the first electrode and the response that it generated, I believe. Hold on, I hope that I'm not, let's see, image 7. Yeah, this should be the first one, channel 1. So it generates a pretty strong response. Channel 2 does not have as strong of a response because I typically don't get a good fit on that. I believe this is channel, let's see, I unfortunately don't have labels on these photos. So let me try to, I'm going to stop sharing and let me just try to reorient which photo is which. Just a moment. Okay. Channel 2, channel 3. All right. So these are, all right. So this is channel 2, which has a bad fit. Let me go ahead and share the screen again. Okay. So this is channel 2, which has a bad fit. That's why the correlation isn't very good. This is channel 3, which also has a bad fit, but slightly better. And that's why the correlation isn't very good. So electrodes 2 and 3 really don't seem to fit. Electrode 4 has a good fit for me. And so this one comes through very clearly on the correlation. Electrode 5 has a good fit for me. So this one comes through very clearly on their correlation. Number 6 tends to have a very poor fit for me, just like 2 and 3 do. So for me, the pattern is 1 and 4 tend to have good fits. 5 and 8 tend to have good fits. 2 and 3 tend to be a little dicier, and 5 and 6 tend to be a little dicier. So anyway, this is of the rear 4. This is 5, the one that has a good fit. This is 6, the one that has a poor fit. This is 7, the one that has a poor fit, and this is 8, the one that has a good fit. So yeah, there is clearly we see which electrodes, and the idea here was to kind of like identify, okay, where are we seeing the signal from? Now, with the particulars of the crown, because it's a fixed design, it's a hard shell. As a result, some electrodes just make better contact with my head than others. And this is true for any like fixed, it's true for the Muse, it's true for the whatever. I don't have a perfectly symmetrical head. It turns out I wasn't aware of how asymmetrical it was until I started doing data collection. I'm very aware of my funny shaped head, or not quite perfect sphere. I believe that's what the physicists would call it. Let me also plug in the Emotibit. One of the cool features as well is that you can charge while recording. Not every device lets you do this, but the Emotibit does. And I thought that was pretty neat. Okay. So now it's got that friendly orange electrode. By the way, the lights on this thing are pretty useful. I'll fire up the oscilloscope here for a second, and we are going to look at it as well, but I figure, why not? I don't launch it for a moment. Yeah, you should see the blue light now that it connected. Let's see, sorry, the straps are in the way. There we go. The blue LED lets you know it's connected to Wi-Fi, and the orange LED will pulse every time it's sending a data packet. So this ended up being quite useful. I always love yes. This is a device called the Emotibit. So let's take a look at what the Emotibit features, and then we can take a look at some of the data. I think we've got that on. Okay, so with the Emotibit, share the screen. Cool. This is what we've got. You can see heart rate. You can see EDA, electrodermal activity. You can see room humidity, and yes, it is humid in here. You can see the accelerometer, the gyroscope, the magnetometer, as well as two different temperature sensors. The therm sensor, I believe, Emotibit was considering having two different sensors depending on which hardware package you bought, a regular thermometer and then a medical grade thermopile, whatever. So I don't know which one of these is the better sensor. One is fancy. The other one is less fancy. They seem to report fairly similar measurements, which is good, I guess, if you get the same data in two rather novel ways. And yeah, over at the electrodermal activity, it is pretty funny. Just watching the various things, like, you know, as I make statements or whatever. Okay, so let's try the electric shock game while we're at it. Oh no. Okay, so oh boy. Okay. Yes, minimum of 2 players. That's great. Okay, so here's going to be the fun part. I'm going to start this mess. You're going to hear the music that lets you know that I'm about to have a good time. And yeah, then I get the shock. So the thing we're looking for is when you hear the music cut out, you're looking to see if there's a spike in the electrodermal activity or potentially some of the other metrics. Who knows? As you can see, the anticipation of this is definitely palpable. Okay, let's try this. Oh man, do I not want to do this. Oh, darn it, it didn't do it. Okay, so that was a disappointment. I have to do it while the music is still playing so that I trigger the I was too early response. By the way, the dip there was my negative surprise. Like, what do you mean it didn't go off? And it's pretty funny that you can see that clearly. All right, let's try this again. Man, this electrodermal stuff is hilarious. All right, just a moment. All right, so that sucks. But yeah, that's what that looks like. Yeah, well, it seems like getting an electric shock changes your heart pattern or something. And yeah, the whole experience of shocking yourself on stream generates a very large electrodermal response. But yeah, there we go. And now that that's over with, and I'm considering putting this thing away, it is trippy. It is genuinely trippy that, like, I'm like, hey, you know, I think I'm done shocking myself and I can watch this thing drop. It's pretty funny. All right, I'm going to stop sharing the screen for a moment. Let's see if, does anybody have, would you like me to shock myself again? Let's run a poll. Oh, man. All right, so we're using that poll functionality to the fullest. I'm going to go ahead and share the screen again. Let's see what we're doing. And yeah, so let me try taking some screenshots or even just writing down some metrics. But, you know, this electrodermal is definitely dropping, 1.03. Yeah, it's really interesting how responsive it is to state. Like, the moment I started, you know, using this thing, it completely moves around. But then, like, yeah, all right, I'm gonna do it again. That's fine. Let's get this over with. And then I really want to put it. That's ridiculous that you can literally see, like, I'm sorry, that really cracks me up. That really cracks me up that you can see exactly how I'm feeling. Because I'm not excited about it, but we're doing it. Okay, so let's go ahead and start the music. All right, that's what we have. And the funny thing is, the more times I shock myself with this, the less unpleasant it is. I don't know. I don't think my electrodermal numbers show that off. They're still pretty high. You know, 1.0 is where we were before I started zapping myself. 1.3, I guess, is where we are now. But yeah, I guess. Oh man, one more time. Let's do this for a third time. Yeah, it's funny. Like, the moment I pick up the controller, I don't know if you could see it. Like, I've got it in my hand and, like, it goes up a little, you know. And then let's start the music. You'll hear it start. All right. So yeah, actually that GSR dip is really interesting. I really don't know if that's me anticipating the shock or what, but it, you know, well, I'm getting shocked in my right hand and the emotive bit is on my left hand. So I wonder if we would need to get precise with the timing, but I really wonder, is it some kind of anticipatory, you know, distancing yourself, like preparing yourself for the thing you're about to experience, or is it the electric shock? I think that's going to be an interesting question to look at. So the main reason that I wanted to do that, other than just for kicks, is that this is it. Yes, the moment you're hearing the honk horn, that's the exact moment that I'm getting the shock. Well, I'm triggering the shock by pushing the button down. I can't anticipate it because I know I'm about to push this button. The way this game works is it requires a minimum of 2 players. And once the song stops, whoever hits the the thing later, whoever has a slower reaction time, is the person that gets shocked. But there's another condition to the game, which is if you push the button too early, if you push the button before the song ends, then you also get shocked. Like in Jeopardy, you're done, once you buzz in. So in this case, the easiest way to trigger it with a single person is to push the button while the song is still playing. So I do know exactly when it's going to happen because I'm pushing the button. So that's why I do consider the idea that that's a anticipatory drop. And I think Rashi brings up a great point, which is the electrical aspect kind of makes a confound. And that's always the issue with this, right? Which is like, how do you cause pain to yourself in non-permanent ways that you can measure reliably, and that also maybe you won't hate yourself for? And so the spicy food is the one method that I found. And this, again, it's a party game. People willingly play this. Oh no, I'm not touching it. Hold on. Does the music? It does. Oh man. So I get tense with the music, even though I don't have it streaming. Hold on, I'll share it. It is a cue. Yeah. So it was at 1.3. Or it could also be my embarrassment at botching it as badly as I'm doing. So it's one of those two. But it was really interesting because I was just kind of sitting here at 1.3, and the moment it started playing, in this case, I don't seem to be fazed by it at all. But yeah, it's pretty trippy. Now, see, I'm like, this sucks. This experiment sucks, and my skin response is definitely spiking. So, sorry about the music. Yeah, it will. Yeah, that's me. That's me getting shocked unexpectedly. That spike. I went to go move it, and I touched it. I wasn't expecting that it was shocking you when it was still in the base, but it is. So, yeah, this is really interesting. So, what I wanted to mention is what I find so fascinating about this GSR data is it's quite different than the EEG data that we got for the spicy challenge. And let me explain what I mean. When you look at the spicy data, let me go ahead and share a few of the plots there. Okay, just a moment. Is this the one? No, of course not. Hey, this is the one. Okay, great. Okay, so the spicy challenge, where we're looking at some conditions. These are the recordings from August. We have some from September. I did some tonight as well. But the really clear thing that comes through is, like, if we were looking at the EEG, like, here is the delta response, and it's really, really clear and significant right when the stimulus gets administered. There's no anticipation. I mean, maybe a tiny bit, but the difference in power is really massive. The theta response, same thing. And we're using channel 1 because that's one of the good ones in terms of signal quality. Definitely agree with Rashi on his assessment there. Alpha, we get no response. Beta, we get a strong response. And gamma, we get a strong response. So when it comes to the brain EEG and capsaicin, there's a really clear, really specific, really immediate reaction that lasts for about 2.5 minutes after you do the spicy food. And I've actually got the, let's see, 5 trials corrected baseline. Yeah, so here we put 5 trials together. No, wait 1 second. All right, cool. So here we stacked 5 trials together. These are the baselines only. These are the spicy, and then where do you get, right, the 3. All right, cool. So here's the baseline and spicy. We had a bug in our code that limited how many we could do. We fixed it, but I haven't rerun these reports. Anyway, let's look at channel 1 across those 3 responses. So you can see that on 3 recordings where we do baselines, we get nothing. And then on the 3 recordings where we do the stimulus, and that's going to be the gray, that's the mildest response. The orange is the stronger response, and the blue is definitely the strongest response. But yeah, you can see that in every case, you have a response when you do the stimulus, and you don't have a response when you do the control. The theta is even more clear. You know, you got the gray, orange, blue again. The beta really comes through. I mean, this one, there's no doubt, right? It's all happening across the bands, really, really straightforward. And then the gamma has a really strong one in EEG. So there's something immediate. There's something that, you know, spikes and you can measure. That's what happens in the EEG when you administer capsaicin. So I was really curious, like, okay, so when we administer capsaicin with the Emodibit, what are we going to see? And yeah, interestingly enough, the skin response does not change with the capsaicin at all. I was very surprised, but the anticipation, the lead up to it, yes. So I have 2 recordings. Now these aren't going to be quite as nice as the other ones, because these, I'm just sort of like grabbing the CSVs and plotting them in Excel. So it's definitely going to be a lot more kind of like what you would see if you were just sort of iterating with this on your own. But I think this is a good exercise. Let's step through it. You know, how do we do some initial analysis? And we're just going to look at the time series and see if we can interpret them. So we'll go ahead and share the screen again. Cool. So let's look at some recordings. This is whatever I put together. Okay. This is the wrong. That's the right one. Cool. So yeah, if I sort by date modified, you can see some of the recordings I did today. So here is a baseline, and I wanted to show you the electrodermal activity. Cool. So if I plot this line, this is pretty much the same thing as you're seeing in the Emodibit UI. Now, I was kind of chugging along here at 1 level of skin conductance with some slow rising, which is standard. And then something happened. What happened? Well, I wasn't trying to induce any stimuli. I was trying to give a clean baseline, and my phone decided that it was time to notify me 10 minutes ahead that, you know, I had a meeting scheduled. So it caused like this immediate annoyance for me, which was like, geez, you know, I'm trying to do a baseline. I've only got a limited amount of time. You know, why does my phone need to notify me so often while I'm trying to do these things? Anyway, and so it's really funny because here in this data, this is a big change, and this is the moment that the notification came in, and this was kind of like me getting annoyed and dwelling on it for the remaining 2 minutes, going, I bet this is going to be unusable, and that. And it's embarrassing to me in some way that you can see that. I mean, I don't have to tell you folks that, but I mean, I figure it's worth knowing. But it is hilarious. Like when you look at your own data and you realize, holy moly, this is really my irritation factor at like not getting a clean baseline. So here is the electrodermal for the spicy halfway through. And I mean, okay, do we have like a slow rise? Sure. Do we see some changes? Yeah. Is there a big shift before and after? No, I don't see anything. Maybe you could say that this is a little sharper. after than before, but I think it's so subtle that I would say, to me, these look identical. So I think that this is a really, really, really interesting thing to distinguish, which is galvanic skin response is really your emotional state. And it's much less to do with your cognitive state. And I do think that is really cool. I mean, yes, I'm rediscovering the wheel. Yes, I'm rediscovering that GSR is good for psychology experiments, stuff we knew 100 years ago. I do get that. But it is cool to have your device with, a pipeline that you understand. And then to kind of see like what stimuli generates what responses and how. So I do have to say that was like super cool in the sense of the spicy challenge that we've already done before, that we've already looked at the data and we had some idea of what to expect, turns out to have very interesting findings when applied to some of the other data. The other sensor, unfortunately, doesn't come out in the Excel plots, so you'll have to take my word for it, or if you just wait a little bit, I'll have a plot that looks nice and backs this up. But skin temperature did not change at all either. So I wasn't sure if, I don't know, your skin would flush or do something different because of the stress response or whatever. But yeah, there was no skin temperature changes there either. So I thought that was kind of cool. You were able to see some of the stimuli tonight, but yeah, for whatever reason, the GSR like really picks up the emotional experience of this much more than it picks up the shocks. And of course, like when I get touched or when something happens that's surprising, you'll see a spike, and that's very worth knowing. I think GSR spikes are used for exactly that kind of detection, but it's still interesting that a lot of it has to do with how you're feeling, the nervousness of like, hey, I'm going to be measured. What am I going to record? I mean, whatever. Maybe other people don't experience that as clearly, but I just thought it was definitely pretty cool. So we have electric shocks. I can't think of too many other experiments we can try running. I could try, we could validate some of the other sensors in terms of, but let me just ask, is there something to do with skin conductance or psychological state or stress responses that you think we could maybe try? I could also get the crown if you want to try including some EEG data. So that's definitely something we could do. But yeah, let me know if there's any experiments that you would like to do on that. And then let's see. It kind of sort of does. It's mostly EEG. Muscles will generate artifacts in EEG and you can process them. But I think with the way that it's designed, one is trying to get the least noise and the least muscle movements in the data. But you will see blinks, you will see muscle movements, you will see if you talk or if you do anything like that. Yeah, that'll definitely show up. Okay, well, one of the things that I was thinking we take a look at, I'm not sure that we can implement this tonight, but I thought this would be good to take a look at. Morgan made a great suggestion that we take a look at the website of Micah Allen, who's a neuroscientist, and there's a website that they have right here, the ECG group, Embodied Computation Group, and I think they're out of Denmark. And yes, there's a GitHub that has a whole bunch of cool projects and things that they've made available. So there's this Cardioception, which allows you to measure interoceptive performance with CycloPy. And then the other one that caught my eye was the Systole package. So the Cardioception, which is pretty cool, lets you measure, um, you know, cardiac interoception by asking participants to count their heartbeats for a given time, and then look at the accuracy. And then in this case, where they have to estimate the frequency of their heart rate by comparing it to tones. And yeah, so this is a Python package that would let you potentially do this experiment. Now, I haven't tried running it on myself, so I don't quite know how much drift is normal, like how far off are people usually when they make these guesses. But it is cool that that there is a package that we can use to do this analysis, and then it's pretty much good to go with GitHub. So I think that we do plan to give this a shot, although I'm not sure. The first one, the systole package, I think we're definitely going to start with this or something similar, because we've got 3 PPG sensors on the Emotibit, and you know, it's useful to be able to turn it into like this kind of data. So you have like the ECG, you have the beat-to-beat detection, you have the instantaneous heart rate, and then you can do the epoching, artifact detection, rejection, and so on. So what I'm hoping is that we can get these, I mean, you know, depending on how much work is involved adjusting the Emotibit data structure for this particular Python package, I think it would be cool that potentially on next Hack Night or the Hack Night after, that we could show this kind of data. Now, with heart rate data, I think it already starts to get interesting in terms of most devices don't try to show you the beat-to-beat cardiac, because that's where you can do a lot of that. And so I think in our case, you know, having a package like this lets us choose the kind of analysis we're going to do and then what gets presented to the user as well. So yeah, I think that this is going to be a really neat one to check out. And once we get this up and running, I think we can grab some Emotibit data and take a look at what we see in these plots. I think that'll be kind of like a really interesting one for the Hack Night. So yeah, no, it's wonderful that so many labs around the world are sharing their code, making it available on GitHub, linking to it in their papers. I mean, these are really big steps. When science is harder to reproduce, it's a lot harder for validation, and it's a lot harder for people to build on that knowledge, even just, you know, gaining their own functional understanding. So over the past few years, all these open science initiatives and data sharing initiatives have really been a wonderful sign. And UCSD, Bradley Wojtek's lab, has published a lot of really cool stuff that we were able to implement, the FOOF and some of the other things. And in this case, this is an additional one that we can use to implement the functionality. So it is great to know, like, hey, these tools are good enough to be used in a research setting. People in actual labs find this valid and useful. So presumably they applied their domain knowledge into saying that, yeah, this is sound, this is verifiable. You've got the source code, so you can reconstruct their calculations, which is cool. We did actually do some of that with M&E, and it's a painful process, but you can definitely do it. And yeah, and then here you can pipe your PPG data into this. Now, it would be also interesting to see the PPG data from the Muse 2. A lot of people in the neurotech community have Muse 2s. Muse 2s do generate PPG data if you're using BlueMuse. So this could be a cool project that people that have a Muse 2 can get their heart rate information when they're wearing the Muse device and plot it in a useful representation. So yeah, that's something I'm very excited to try to implement, and I think we can get that rolling for next week or the week after, something like that. Okay, well, let's see. I think, unless we can find some interesting neurotech news to talk about, that I am sadly running out of material for us to discuss. But I know, I'm terribly remiss. I'm going to go look at Slava's awesome posts. And already we're good to go. Look at this. This is beautiful. Cool. So the first one, kernel. Oh, yes. Sorry, Itamar. Let me link you. This, thank you so much for asking for that. Here is the Cardioception repo. Let's just do their whole embodied computation group repo. And then this was the last one, the systole. And incidentally, the Emotibit is very comfortable to wear for extended periods, which was a major criteria for us. If you've ever tried using the shimmer GSRs, the one that require like your hands, it's just annoying that you've got something strapped to your hands. I think Empatica discovered that the wrist is like a great location for GSR. And the traditional place that, like, you know, if one had their pick would measure would be the bottom of the palm, not the top of the wrist. But it's like Empatica once again found that the wrist was a really good real world trade-off. So maybe in a lab, if you were just doing like an experiment that users could do with one hand, then you could do the other one with like a full palm setup and so on. But I do think it's wonderful that the Empatica wristband is about $2,000 and it's difficult to get the data off of it. This is $400 for the fancy version, and let's say $450 with the case or whatever. But yeah, that just really makes it a lot more viable for what we're trying to do. Okay. Kernel and Cybin, which is a biotech company. So the way that I am really thrilled that we are exploring psychedelics and how they can help people. I think there was this unfortunate period where we chose to represent them as the worst thing possible without really knowing that that was the case. But I think that now that we have that behind us, this is a wonderful thing to see. And I do find it fascinating that the same pharmaceutical companies that probably were not interested in psilocybin being approved for the longest time are now making a lot of money using it, which there's no moral component there, but I find it bizarre that, you know, companies would advocate against and try to criminalize a product for decades. And then when it finally kind of turns around, it's like, oh, wait, we can make a ton of money on this, right? Like, I'm glad that the profit motive has made us be pragmatic. And I'm glad that these kinds of studies are more and more prevalent. There are so many labs, real research labs, and there are so many pharmaceutical companies, and there are so many pilot studies that have been authorized testing the effects of psilocybin. And it's just amazing. So, okay, let's see. What are they talking about? Ketamine? Are they talking about what specifically they're going to be testing? Let's see. Psychedelic therapeutics. Ketamine's psychedelic effects. All right. So ketamine therapy has been approved and is gaining in popularity. I like it. For decades, you have not been able to have mushrooms. But what if that was to change? All right, so cool. This video doesn't seem to have a lot of information. I'm sorry, ketamine. So leveraging the kernel flow, this is really cool. I'm sorry, I don't mean to make light of this. I'm really happy that we're exploring these substances and that finally we have made the choice to kind of like explore the therapeutic aspects of this. This is really cool. So yes, ketamine is a go. Get a kernel flow and you can go ahead and administer some studies. I do think that this is, let's see, I think we also had some psilocybin news, but I will see if I can find that. And I've been mispronouncing it. I apologize to everybody that was cringing repeatedly. And to all of you that are watching this on YouTube, yeah, this is the moment where I realized. Can we see the galvanic skin response? It's no good. Kernel flow uses two kinds of sensors. It uses FNIRS sensors and it uses EEG sensors. They have an array of pods that go around the head, and you can choose whether to configure each pod with either an electrode array or a near infrared spectroscopy array, FNIRS. So what's cool is that it's kind of like this combo device where if you want it to be really EEG heavy, you can do that. If you want to have mostly FNIRS, you can do that. Or if you want to have a mix of both, depending on locations, you can do that as well. So the sample rates, the portability, the fact that it's a unified device, the fact that you can configure it for what you need, I think are all the things that make kernel very, very exciting to universities and researchers. Hey, congratulations on your Neurosity crown. Let's see. I would suggest doing some experiments with a couple of different conditions that you want to measure. So you can start with like do a recording where you're just with your eyes open, staring at a blank screen or staring at a nothing. And that's called a baseline. And so that's going to be kind of like the starting point for these are your signal levels at rest. This is when you have no stimuli being applied. Now, obviously, you might have some ambient noise. You might have a car drive by. You might have some other stuff. But for the most part, it's going to show a representative example of your brain data. Then once you've got that baseline recording, then it's really good to record a couple of stimuli and see how your data changes. So stimuli you can record are reading a book or an article. That works. You can do it screen-based or you can do physical. Whatever causes you to move your eyes less is probably going to give you cleaner data, but it's not something you need to worry about too much. Like if you find that like a book works way better than a screen, or if you find that a screen works way better than a book, use the one that works better. Right? It's just that it's going to be one is going to be more suited and the other one's going to be worse. Once you've read something, then I would recommend watching something. And then you can try doing something. Like, I don't know if you do anything computer-based, but like writing an email, playing a game, solving a Sudoku puzzle, doing a crossword, anything like that that actually involves you actively thinking about it. Once you have those comparisons, you can also try altering your behavior, like sleep disruption. Not that I'm saying, you're excited to do that or anything like that. But if you wake yourself up, it's an oddball time, put on the crown, see what kind of brain signals you've got. Same with, let's see, food. It turns out we did the spicy challenge. So if you administer capsaicin while you're wearing the crown, you will get a strong EEG response. That's what the spicy data is that we were looking at. And yeah, by the way, we can process your data. Like if you don't have a pipeline ready to go to analyze this stuff, if you're comfortable sharing, you can send a data over to me. I'll run it through the same analysis that we did for the GitHub, that we did for the data that we collected. And yeah, so like John Griffiths contributed data, Richard Waltman contributed data, I contributed data, and I think 2 other people contributed data. So it's only like 5 people that have done spicy data so far. And yeah, but you don't have to share your data if you don't want to. My point is, if you want to analyze your own data, I know for a fact that we can take the Crown data and give you some reports back. And this is what the reports would look like, so you have an idea. Cool. So this is what, you know, an EEG report looks like. You get to see the power spectrum on each electrode. As you can see, 1 has a nice fit, 2 isn't, you know, as great, 3 is quite bad because the signal is cut so much. 4 has a good fit, 5 has a decent fit, 6 does not have a great fit, 7, all right, whatever. 8, we're back to good, and we have a spike, which isn't great, but it's there. It looks maybe even a little harmonic, but okay. So yeah, this is the first part. You can look at the channels. Then you can look at the power spectrum. This will show you like the frequency response. We notched out some stuff where we were getting spiking at the Crown. You can also see like how good the fits are. Like, okay, channel 2 is kind of off on its own. The other 3 generally agree with each other, but purple's got, you know, a little sketchiness at the low frequency, which is channel 3. So yeah, like in this recording, you know, I would say channels 1 and 4 are definitely the best. For this set of 4 electrodes, 5, the blue is pretty good. 8, yeah, 8 is actually dicey on this one, right? And that's why we see the spiking, because we've got noise here, which we don't want. So 5 is good. Yeah, 6 is good-ish, but 5 really is the clean one on the second set of 4 electrodes. And then you get these quantifications. This gives you the parameters of your oscillations, so you can find like your peak frequency, your bandwidth, your power. This lets you put numbers around your oscillations, your brain data. And then you'll have this, which kind of shows you the frequency range. Like for each one, were you mostly in the high frequencies or the low frequencies? Within a recording, this isn't going to show you anything interesting, but comparing 2 different recordings will let you see the conditions. And this shows you the power over time. We need to rescale these plots for the Crown. The Crown is a lot more sensitive than the other devices we were using, which means that the spread between the channels ends up being a lot bigger. So yeah, right now the delta is blowing out the whole axis. But you know, in some of these charts, like channel 2 is unreliable, but yeah, you can see how this kind of works. So yeah, this is the, oh yeah, and then you get the ratios of all your bands. And you can kind of, oh, okay, you know, this is my state for that. So what I would suggest is, yeah, do a few experiments like that. Store the data. If you're just using their portal, it'll save it as a CSV. And then if you send you can contact me on Slack, or I'll also give you my email, whatever you prefer. And then just also Slack. It is. That's what's really interesting about it. EEG is really good at measuring brain state. It really is. I don't know how much you feel comfortable talking about how you intend to use that information, but that's actually one of those things I really want to know. And you don't have to share details that you're not comfortable with. But is their focus metric real? Oh yeah, that really measures like how zoned in you are to stuff. Is that your ideal state? That's a good question. I think for most people it will be. How long are you trying to maintain the focus state? I think it's a good question. What incentive do you have to increase your focus state? And I'm sorry to ask such a pernicious question. Is it for your own projects? Is it for work? Or do you see, both of them as beneficial? Anyway, yeah, that's where I'm really interested in. And I leave this question to anyone. If you knew perfectly well, if you had if you could wave a wand and get a graph of your focus all throughout the day, with let's say the morning when you're fresh, you're at 100, or when you're productive and cranking through stuff, it's really high. And then some part of the day it's lower. Let's say it's in the afternoon or the whatever. What does one do with that information? And I'm sorry, I know it's such an obvious question. Is it about changing the times when you do things to match the focus? Is it to compare the difference between work output that you do in that flow state versus not in that flow state? And by the way, please don't think of this as me doubting the validity of the metric or the utility of it. I genuinely would like to know what application people have in mind, because it's really exciting to me. I would love to know. So, okay, let's say you can identify exactly when you're in a flow state. And let's say your flow states last a half hour. And let's say you've got 3 of them per day. So you've got a flow state between 11 and 11:30. You got a flow state between 3 and 4. And you got a flow state between 11 p.m. and 11:30. I'm just spitballing here. What do you do differently knowing that? And I don't, I'm not demanding an answer or anything like that. I'm just curious, like what, I don't know that I'd be able to organize my day around my flow states, but I would want to know what they are. And let's see, if I knew I had something important to do, like an email that I really wanted to get right, or a presentation that I wanted to schedule, I would try to overlap that time as well, right? Like, let's say if I know 11 to 12 is a really good time for me, maybe I schedule really important meetings at 11 o'clock. That seems good info. Maybe if I'm working on a book, the Great American Novel, maybe I write, during those times, and maybe like Itamar suggested, maybe I rest or I organize other stuff around that time. But I guess I'm really curious, like in a typical office setting, what one does in that. I don't know. I can see it for writers. I can see it for journalists. I can see it for painters. I can see it for a lot of, even for programmers, I guess, if you know when your best time is, and maybe you've got like the hardest part of your code, like the really grungy module or something really low level that you got to get right, I guess you could save that for the tough part. I don't know. You tell me whether any of these sound like things you would actually use it for, or whether these suggestions are wildly off the mark. It just occurred to me we might be getting YouTube questions. Oh, okay. And how are you imagining it? Just informative? No, that's beautiful. Oh, really? I don't mean to put you on the spot, but I would be happy to invite you on the stage if you would like to speak to these, or if you prefer to type, then I'm very happy to chat with you via text. Okay, great. All right. So, and by the way, there's only 3 of us here, plus whatever folks signed up for watching this on YouTube. So please don't feel like pressure. This isn't, we're not a big audience. We're three neurohackers talking about biodata and ways that we think we could use it. So if the camera's giving you a hard time or any of that stuff, no worries. We'll get through it.
No problem at all. And thank you so much for organizing this. And you've been doing it consistently. So uh, I'm I don't know if this works honestly. Like it's something that I want to figure out because I spoken to some people who are like neuroscientists, and they
Mm-hmm.
are very skeptical about technologists in general. Is what I gauged.
Mm-hmm.
Uh, I generally believe that like the moments when people are deeply immersed in flow in certain activity where they lose their thought patterns, their self, like a lot
Mm-hmm.
of spiritual traditions talk about that as the purpose of life. And
Oh
I
wow.
see this movement connecting with the what is it called transhumanism movement,
Mm-hmm.
and like we can use this technology to create optimal mental states for people,
Right.
so like to actually measure emotions that distract people, that give them a hard time, and directly solve the problem of happiness.
Mm-hmm.
I do believe that, like, at least for me, like, I want to live my life where I can maximize the time that I'm in flow, because
Mm-hmm.
it is like of a axiom for me that that
Mm-hmm.
is what is like what I want to optimize for life for. And
That's
if
wonderful.
this device works, then
Mm-hmm.
that is possible, because you can increase what you can measure. So
Absolutely. So a couple of observations. Neurofeedback is incredibly real. And yet, it's something that's hard to prove in a clinical setting. And I think that this sort of really ties back to something I was saying earlier, which is when you can see your own biodata, there is a visceral aspect of the experience that is very hard to describe. I can tell you over and over that it's profound to see your own data, but there's something about it. There's something about seeing it and realizing that it's true and realizing that your experience is on a plot or, in a data point or something like that. And I'm sure that if you can, here's how I imagine the use of their product working, and only because I haven't tried using it to improve my flow. So just going off that, what you're going to wear the device, and it's going to be looking at your brain patterns. Now, there's a variety of ways to measure focus. There's a general way, and then there's like super task specific ways. All of these devices are using the general way because of the nature of data collection and the way you would do a classifier and so on. The thing is, the general approach is often extremely effective for certain things. So in the case of Muse, they measure meditation just by your alpha. And I don't mean that to sound like it's, oh, that's not robust. No, actually, alpha is a perfect predictor of how well you're meditating. And that kind of brings up this deeper topic of some people are skeptical of meditation. Some people are skeptical of this and that. And I totally get it. But for people that do meditate, they really see an improvement when they start using the Muse. Now, there's a lot of feedback that people don't like the experience of, okay, when you hit a flow state, then it starts chirping these birds, which takes
yeah,
you out of the meditative state. And so, like, the first few times people really struggle with that, because they get focused and then the birds start to tell them that they're focused and it takes them out of focus. But once you get over that, it's more like if you were trying to measure something in a lab across a bunch of different people, when you sum, average, quantify, and compare the data, you're not going to see these effects. And it's because like the variations between people are different enough that things just wash out. It's hard to describe, but when you're trying to do big groups and averaging, you often get very weak effects because of how contradictory people are. When you're working with a single person and you pick something specific to them, and this is why neurofeedback is kind of powerful, but it's also why scientists, I think this is my interpretation of why they're so skeptical, is subjectively people report these profound experiences, but when you go to measure it in these large groups, you don't find the effect. So it looks like BS. I think it's incredibly personal. I think it's something, digital medicine thrives when it is customized for the recipient. And fundamentally, by its nature, it can be customized, unlike traditional medications, which are just, what you make is what you got. So yes, in the same way that I was like, wow, the Muse meditation thing is real, the Neurosity device has some of the best signal quality that you can get on the market. So in terms of like a legitimate EEG, it's a $900 device. It's giving you $5,000, $10,000 EEG quality. So that's the first thing, right? Which is like, how legit is the data? Legit. Now, the next part, how good is Neurosity at analyzing the states? Pretty good. And I don't want to go into why, but they have an incredibly robust program. And I would really trust their focus metric. They've done an amazing job with it. Now, what I'm so interested in is, I guess, have you had a chance to use the Crown at all?
Colonel, sorry?
The Crown. Have you had a chance to use the Crown before?
I saved up. Like, I wanted to unbox today.
Oh,
like,
yeah. Okay, awesome.
To meet you guys.
Okay, please, if you would like. We would love to have you unbox the Crown. I can help you with, there isn't too much to it, but I can actually walk you through the setup to get you online and so on. There's like a phone app, and then you pair the Crown with your Wi-Fi, and then you can see some of your data in the console. So if you would like to do that, I'd be happy to. In fact, I'll go get my Crown, and we'll crown along with each other. That's horrible. We'll check our Crown data together. So just give me a minute. I'll be right back, and then let's get you up and running. This is awesome. Thank you for saving my hack night. Thank you so much for joining us tonight. I'll be right back.
So yeah, this is the Crown.
Okay, I'm back with the Crown and the case and the boxes. Ah, yes, welcome to the Crown Club.
Oh, you didn't buy a case separately? I didn't get a case.
I might have. I bought a combo package that included a case. But how about this? If you're in the Bay Area, you can have one because I have a spare.
Awesome.
So next time we meet up, we used to do in-person meetings at like the Red Victorian at Noisebridge. The pandemic kind of shut us down, but I think we're really hoping to resume sometime next year, just when we kind of have a sense of what's going on with that. But yeah, if you would like, I could even potentially mail it to you if you need it. But yeah, so this is the Crown. And what's cool about it is it has Wi-Fi built in. Okay, so first part, how do you wear it? These two go in the back of your head. And this stuff, the arms are a little flexible. Don't worry, you won't. I don't want you to break it, but like you can move them a little bit. It's not gonna resist. The processor is in the back. Okay, so here's how you fit it. And this might actually be best with a mirror, but I'm actually going to show you, since I'm bald, this is a convenient demo. So you see how these electrodes are fitting on my scalp, my skin? That, let's see if I can get you a little better light. This is high quality stuff. Who wants to stare at my skull? Well, join the Hack Nights. Okay, so you want this to make good contact. So like here I've got a gap. That's no good because, you know, if I can't feel the electrode touching on my skin, if it's loose like this, you know, if there's an air gap of any sort, then I'm not going to get a contact. So in terms of height, you don't want this too high. You obviously don't want it on the top of your head, but you also don't want it too low so that it's, you know, on the bottom of your head. So basically what you're trying to do is you're trying to find the angle and the width where these kind of fit comfortably. So like for me, this is such awful footage. I can only imagine people are going to uninstall their YouTube after this. But yeah, like right here, you know, you've got like a good contact. Here I've got a good contact.
Are you supposed to put it at a specific location, like where they're looking for certain, you know, parts of brain?
You could, but you know, the brain isn't really that localized. I'm speaking heresy here, but for EEG data, you're not going to get huge differences based on where you do it. I would say wear whatever is your best fit, and I would not worry about the electrode location. So I find that with these arms, I configure the left one a little different than the right. Like I actually have them on, again, my skull is not symmetric. So yeah, if you have this device, what you're looking for is in a mirror, you want to feel the friction of the electrode on your skin, right? And that's what lets you know that the electrode is making contact. Because if you can feel the friction, if you can feel the poke of the rubberized electrodes on your skin, then you have good signal. And if you can't feel it, you can also move your hair depending on how thick it is, but you want it to touch your scalp. You want it to touch your skin. Okay.
How do you turn this on?
Great question. So there is a power button here. That's this LED. If you hold it for a few seconds, it should turn on, and it should have an initial charge. Now, do you have... Oh, hi, Ibrahim. Thanks for joining us. Yeah, absolutely. We're hacking on the Neurosity Crown EEG tonight. We've got someone setting one up for the first time. Yes, absolutely. And I'm so excited. Okay. Phone app is the best way to get this up and running. Do you have iOS or Android?
iOS.
Great. That app is a lot more stable than Android. That's the only reason I ask. So you're going to have a good experience using iOS. Download the Neurosity application. And basically, the way that this process works is your crown will come up with an access point. It's actually got like a Wi-Fi base built in, which is pretty cool. Then your phone will connect to the Wi-Fi network on the crown and give it the Wi-Fi info for your area. Once that's done, the crown is going to reboot, and then it's going to connect to your Wi-Fi. And then you can you can also associate it with the Neurosity account. Once you've got that Neurosity account, you can either use the app or the console online to look at your data. And I'll show you how to use all that stuff.
Like, do they own the data? Do they keep the data? Or like, can I store it on my machine?
You can enable what's called local mode. None of the data will be sent to them, and it will only like work locally.
Okay.
Oh yeah, and by the way, if you need to take some time, I hope I'm not messing with you know, but yeah, you can try to find like whatever's the best location.
It doesn't seem that it has a charge. I think I have to charge it.
Okay, great. It should have a little charger, like a travel charger, and then it's got a plug here. So if you plug in the charger, you should see it turn, I think, green or red. Red. There you go. Red. Okay, cool. So it's going to be red for a minute while it's charging, and then then we'll see what happens. So
time to charge, like, is it?
Yeah, let's give it like 15-20 minutes, I don't think it's going to have a huge charge, but it should have 20-30%. It takes about an hour and a half to 2 hours to do a full charge, but I think we can, maybe even less, but I think we can definitely get 10-15 minutes. There's plenty of stuff to do while it's charging. So yeah, okay. You want to download the Neurosity application.
Done.
And go ahead and open it up here. I can even, oh no. Every time I try to join from the Crowdcast, I'm going to mute for a second. No, this, you know what, this always breaks it. I'm trying to like share a link, but there's a different way to do that. Okay. This will be the console that you go to when it's up and running.
Can I turn it on while it's charging?
You can try. I don't know if the initial one, but when it's up and running, you can definitely leave it on, charge it, uncharge it. Like, it actually seems happier when it's on all the time than when you power it off and turn it on. So yeah, basically you can have it charging most of the time and then just unplug the charger when you're ready to do a recording, and then plug the charger back in when you're ready to leave it idle.
Yeah, it did start. It's asking me to tap the N on Neurosity ground.
Great. And if you want, you can, yeah, like let me know if there's any prompts. I don't have a good way to share the screen from my phone. Yeah, beautiful. Okay, add a device. Yes, great. Okay, so, okay, hit continue.
Scan?
Yeah, so I think it wants to,
Or is it NFC or something?
it's got a, yeah, it's got a,
It is NFC, like Apple Pay. It's pretty cool. Like, Muse is Bluetooth, right?
yes, this is NFC and Wi-Fi. It's way better.
While you were saying that meditation thing on Muse, like I tried it. So there's this thing that you hear the birds and you get distracted, but the reverse happened to me. So oftentimes there were no birds. I'm like, oh, I'm not meditating right today. Like, why are
Right.
there no birds?
Oh, really? And was that helpful or unhelpful to know that?
Unhelpful, because like I kind of started craving for, there should be birds.
There is something really interesting about feedback, which is if someone thinks something is working, but if you give them a metric that shows it isn't, it actually really creates this tension. I guess the inverse effect is, in the same way that biodata is an incredibly joyful experience, if you are expecting to see something specific and you don't, biodata can be a very frustrating experience. I guess I'd never really thought about that's the flip side of it, but yeah, that is, I guess in both cases, it's meaningful. It's just, it can be good at
It
that.
says it's connecting to Wi-Fi.
Great. Yes.
It turned
So
blue. I don't know what that means, but
blue means it's searching for Wi-Fi. If you give it about 1 or 2 minutes, what it should do is turn off when the phone app says that it's connected, and then we can then it should come up as white when it's done rebooting.
Okay.
Yes, Ibrahim, if you go back and watch the recording, or if you watch the YouTube, you can watch me deliver a bunch of electrical shocks to myself, and trying to see what happens to the galvanic skin response and finding out nothing happens. So yes, it was the electroshock hack night. The good stuff. It's entertaining, and you can watch me react. You can watch the look of delight on my face as the volts are coursing through my hand. It's that is a joyful experience too, let me tell you. And yeah, you can watch for the anticipation on the skin. Yeah, you should. It's funny. The galvanic skin response is funny, and I'm happy to be. If I can entertain you with a little bit of science, and we'll go from there. How's the The menu prompt's looking good.
Yeah, so the Wi-Fi is still setting up, but this turned white.
Excellent. Yeah, it'll take a minute, and that's wonderful. So yeah, the part that like Neurosity used to have an onboarding process with like this web console and whatever, but for the Crown, they also released this really nice software that you just through a phone pair it right up and good to go. So yeah, I do think it's nice that they made when you know how to do it, the user experience is super smooth. There's a little bit of like, well, how do I get started? But
this looks like this now.
Yes, excellent. So you've got the Crown. Now go ahead and, I don't know if you want to charge it or whatever. It has to do some firmware updates that'll take a while. What's the battery life? 27% it said? Or
26%, yeah.
26%.
Turned yellow again, or green. Yellow or green.
Yeah, it's going to do all kinds of colors during the firmware update. Get ready for like a light show. So that was confusing me too, because it's like half green, half white, or half blue, half green, and I'm like, what it means is it's updating the firmware. That's what that means.
Thanks so much for initiating me into neurotech in some sense. I'm very excited to play with this.
Oh, that'd be wonderful. And in fact, there's a bunch of really, really cool experiments you can do. And so I would just start with different stimuli. I mean, that's where we started. And I had a very fun time just trying random things. What's the difference between a movie and a TV show? What's the difference between a TV show and a video game? What's the difference between a video game and reading an article? What's the difference between reading an article and watching this kind of YouTube or that kind? We even tried two different YouTubes. We had one of like a rally car driver driving through San Francisco, which was supposed to be an exciting video. And then we had one where you're watching a Kurzgesagt video physics lesson type of thing. So we tried to pick very dissimilar videos. And yeah, it's all different. It all generates different responses. And what's cool is if you just go through those experiments, you'll learn a lot about your brain. You'll realize like, oh, in this setting, here's how I respond. In this setting, here's how I respond. And then you can start to infer things about, well, I guess there's some relationship here, which is cool.
Do you do baseline every day? Like, is baseline supposed to be different before every activity, or like one baseline continuous?
If you can, do a baseline before every recording. But baselines are incredibly boring. They really are. You sit there like a not very active person. There are a couple of solutions to that. If you know the target length of data that you're going for, you can cut the baseline length to something shorter, like 2 minutes or 3 minutes. 2 minutes is manageable. 3 minutes is manageable. 5 minutes, for whatever reason, crosses some kind of psychological barrier where I'm definitely bored. Very bored from like 2.5 minutes to 5 minutes. I just want this to be over. So you could just make your baselines 3 minutes, because it's better to have more frequent, smaller baselines than it is to have less frequent, big baselines. Your power levels will shift significantly through the course of the day. And basically, there should be a trajectory where the power gets stronger as the day goes on. So like your power levels are going to be low in the morning and high in the evening. But not everybody has the same trajectory. Not everybody has the same rate of fatigue buildup. Not everybody has the same progression through that stuff. So if you don't baseline, those long-term changes are going to confound your ability to analyze. But if you do baseline, what you can do is you can look at the power levels in the baseline for each recording and normalize from that. Now, this is some slightly advanced stuff, but let's just put it like this. If you do a baseline and later on you start doing some really cool data quality stuff with EEG, then you have the baseline to do those calculations. And if you don't baseline, then most likely you will never care to do that fancy analysis, but you won't be able to go back and do it on data that you've collected before. Yeah. So it's kind of like
a good habit to build, I guess.
Yeah, but actually, I would really stress managing your annoyance levels is the single most important thing in doing these experiments. I really mean that. If you come up with a rigorous thing and it takes you an hour and you hate the experience, you're never going to do it again. Like, nobody willingly subjects themselves to awful things. And yes, that 1 hour prep, where you're scrubbing your scalp with alcohol and putting gel and right? Maybe that's going to give you like 5% cleaner data. You're not gonna want to do that a second time once you do it the first time. Most people are like, you know what, this is awful. So try to find this pragmatic balance between where do you personally start getting tired, where do you personally start feeling like impatient, and that's where I would try to cut. So if you can tolerate a 2-minute baseline, great. If you only want to do one baseline a day, that's still good. And if you'd like to do one baseline a week, all right, there's nothing wrong with that. Whatever gets you data and whatever you can tolerate. I think those are the two most important criteria.
So last question about this. So
no.
have you considered so I recently picked up meditating. Like, that's also just sitting with eyes closed, not doing anything.
Mm-hmm.
I was wondering, like, is that baseline? Like, can I just
Absolutely. But here's the problem. I don't do my experiments with my eyes closed because I find myself, when I'm doing an actual stimulus and I've got my eyes closed, I have this like urge to look around, right? Even though my eyes are closed. So I'm doing all these eye movements behind my eyelids, and that really sucks for EEG. So EEG does not like eye movements, even with your eyelids closed, right? You want to keep your eyes fixed as much as possible. So I find that it's a lot easier to keep my gaze fixed if I have my eyes open. And it's not, and I know that the experiments that I'm going to be doing are always going to be with my eyes open. When you close your eyes, for some people, it raises your alpha levels significantly because of that meditation focus aspect, right? So if you want your baseline to be valid, you need to do it in the same condition that you're going to do your experiment. So if your baselines are eyes closed and you can tolerate doing your experiments eyes closed, then you're great, right? Like, you can use eyes closed for both. But if you find that your experiments work better eyes open, then do the baseline eyes open. And all it is, you're trying to match the power levels that you're going to have during the recording. So your baseline for your alpha is going to be off if you're doing the other condition. If your baseline was eyes closed and your experiment is eyes open, your alpha is going to be way too strong in the baseline. And if your baseline was eyes open and your experiment is eyes closed, then the alpha is going to be way too weak in the baseline, and it's going to look like you have ridiculous alpha in the experiment. So it's kind of like the practice that I use is baseline right before recording. And that's the cleanest comparison you're going to get of here's what it was pre-stimulus, here's what it is with stimulus. But you don't have to adopt that. It's just a good habit. And if it's something that annoys you and keeps you from doing recordings, better to get data with no baseline than to get no data at all because you find baselines burdensome.
Yeah, thank you so much. All right.
Mm-hmm. And by the way, please don't feel any time constraints. We can spend as much time getting your crown working as you like, or if you've already had enough of talking about the crown, you can also duck out whenever you've had your fill. But I'm happy to get the crown on the console, make sure it's on your Wi-Fi, whatever it is, or we can save that for next week if you'd rather, look at it somewhere.
No, I'll come back next week, like, with this setup. Like, I'd love to show you, like, that I worked on it till next week.
Okay.
And it'll take some time to charge, I guess. But thanks so much for I think you gave me a lot of issues that probably rookies fall into. So so I'm super excited about getting started. And and thanks so much for running this community. You're doing such a great job. Thank you so much.
Well, I'm so glad that it helps. And I really encourage you as much as you want to, the more we can help you on this call, the better. Me talking about stuff is great, but our number one purpose is helping people with their projects, helping people with their code, helping people with their data. That's really what we do. And so anything you want to do. There's no, like, don't feel like there's a limit. Anyway, we're very happy to have you back next week. And I'm so excited that you got it working. If the crown is blue, that means it's searching for Wi-Fi. If it's white, that means that it's online and working. And if it's orange, that means that it's, charging. So those are the typical statuses that you see. Red means that it's in a power off status, that it's powering off. And then I honestly don't know what the mixed electrodes are. That's a new thing that happened with that firmware update. So I'm sure they mean something. I just don't know what the white and green combo means. Probably starting up, something like that.
Yeah.
So let me just show you a little bit about the console. And this is, just a preview of what you're going to see, right? But let's take a look at it. So I'm going to go ahead and share the screen. Right. And here is, sorry about the inception thing. I'm going to put this on. All right. So we got Neurosity. Cool. So as you can see, I run mine in local mode, which means that my data is not stored on the Neurosity servers. I'm online. This is my Wi-Fi. And as you can see, my crown number 140 has 77% battery power remaining. So the first thing is, here is my awareness and calm. Let's find out how calm I am.
Don't you need to do baseline for this?
They've already got a classifier built for this, so they don't have to baseline. I'll explain in a moment. That's a great question. But me talking is bad news. On the other hand, as you can see, I'm not very calm. What I would expect to see is a high awareness, because I am, let's see, the focus.
What is awareness / focus and awareness / calm mean? Like, both things have awareness.
Well, that's a good question. It means that they have different definitions for their classifier on the back end. And no, I certainly don't know what they are. But probably, like, let's just use a hypothetical that I know isn't true, because I'm just going to make something up. Let's say this is measuring alpha and this is measuring delta. Now, that's not true. I'm giving you an example. But in this case, it's reasonable that my alpha power might be low at the same time that, like, my delta power would be high. And if that's the case, and I'm not saying their classifier is a single band or anything like that. I'm just giving an example. But in that case, you could simultaneously have a high delta and a low alpha. And that would be a metric that shows the focus side of awareness versus the calm side of awareness. And I don't know why these are both called awareness necessarily. Okay, here's our signal quality. Wow, phenomenal. So
related to, like, have you put your band correctly or not? Like, what does it, or if it's the network is right, like is it trying to capture?
Well, maybe Neurosity will be annoyed with me. What it's measuring right now is standard of deviation of the voltage of the electrodes on the things, which is great in terms of measuring the fit, but it's not necessarily great. Like, this is not a good fit. I mean, you can tell me it's 100%, but this is loose. So, I mean, whatever. So what they're measuring is sort of like, of the electrodes that have contact, how good is the contact? And so I have a few that have good contact, I have a few that don't. And so it's giving me a green. The other way to measure signal quality is using a technique called impedance, where you actually put electricity into the electrode and measure the resistance of the skin. From what I understand, that feature is coming. I have no timetable. I have no, and I don't mean to commit them to it. Maybe they decide not to implement it or anything like that. But I do think a more enhanced version of the signal quality is coming that will give you a per electrode mapping of what is the signal quality. And until then, you've got sort of this coarse metric of, is the data usable or not? And so if it says 100%, that means some of the channels will absolutely give you clean data. And this kind of goes back to this very large discussion of how important and local is localization in the brain. For a lot of neuroscience experiments, localization is very important. Pardon me, I'm drinking some water. For a lot of neuroscience experiments, localization is very important. For a lot of EEG experiments, it doesn't make a big difference. And it's like, oh, well, what do you mean, electrolocation matters? Well, if we take a look at those plots on the reports, and I'll show you the power spectrum displays, and these are off of a crown. So like if you're wondering what device we're looking at, this is a crown. This is what is happening kind of like with my electrodes. And what I can tell you is, like we talked earlier, the blue and the gray have an excellent fit. The purple doesn't, the orange doesn't. So from this side of my head, there are two perfectly... Now, if the data was super different in these locations, then these electrodes would look super different. Now, purple and blue and gray definitely have a difference in the alpha. But I think it's because purple has a bad fit. I don't think it's because this part of the brain is somehow fundamentally different in its signaling than the other parts. So to try to give you a very, very lengthy answer, this just the whole EEG signal quality and what you're getting from the channels, it's like a 2-hour discussion. But to try to give you the synopsis, what it's looking for is probably like, hey, do I have one or maybe two clean channels per side of the person's head? And this is just speculative. I have no insight into their code or their algorithm. And so I think what it's saying is, yeah, definitely you've got one good electrode on the left, you got one good electrode on the right, and you may have more than that. So I think that's sort of the level of detail that you're going to get for now. And then later on, they're going to have potentially the impedance where you can see per electrode, like, oh, this one's loose, or oh, this one's loose, and then you can fix it.
I saw some videos earlier, I think with the Muse, where people were trying to find what is called like P30 or P300. So they were like playing certain. So there's, I think, like at the back of the head, there is some place where you can kind of direct your motor activity or something. And people were playing games. Like somebody built a keyboard just by concentrating on something. So,
yes.
So localization in some way does exist, right?
It does. It does. And this is the part where I continue to kind of... I really wonder what neuroscientists think when they listen to me in the podcast. Yes, but we're continuing down a road of what's the point. And I know that sounds really, really mean or anything like that. I'm not in any way trying to be critical. The P300 paradigm is about finding a change in the evoked response. Let's find the canonical image, and let's look at it. Okay. So an evoked response change, an ERP change, is a change in the EEG signal at some point after a stimulus onset. Now, this is what's happening to the raw EEG. So we're talking about voltages. And what does raw EEG look like? I don't think I have any plots of raw data because they're just uninteresting. I've shown some with the Muse. Hold on. I think I can show you raw Muse EEG data. Cool. Oh, yeah. No. Come on.
Is this like an app from Muse or some developer?
This is an open source GitHub thing called Blue Muse. That was, yeah, it's a really nice app. All right, well, my Muse is being temperamental. We'll look at it later. It's in the raw EEG, and if you're looking at the electrical traces, this is what you see, except not really because it's paywalled. So let's find oddball P300. Okay. So in an oddball stimulus test, and a typical example is I'm going to give you two objects, a box and a ball. And I'm going to tell you, I want you to push a button whenever you see the ball. So the images shown are going to be like, 10 images of box, and then there's going to be a ball. The bottom plot here is what happens when you see box, and the top plot is what happens when you see ball. And hence the oddball name, right? The ball is odd, and it makes your brain go, aha, this is what I was looking for. Mm. And you can do this P300 in a variety of ways. You can do visual P300. You can do auditory P300. Basically, a P300 is a sign that the brain is responding to a stimulus. And it's cool to be able to show, wow, look at this. If we show a box, it generates this plot, this lower one, and if we do this, we generate the bigger one. To do that experiment, you need to localize, but it has no real utility in the sense of, yes, you are detecting the brain responding to a change in stimuli. It has no real meaning. All it tells you is that the brain heard something or did something or changed something or engaged. Now, I'm not saying that the P300 isn't real. I'm not saying it's not an incredible thing. I'm not saying that the experiments with it are valid. But in terms of the stuff that I would use an EEG for, the P300 experiments are like a really cool proof of concept, but there isn't a whole lot you can do with them. I'll give you the ultimate incarnation of the P300 demo. And this is...
can I ask you something? Actually,
please, anytime.
So you asked the community earlier, like what is it like? What is it in for you? As in like what is your like dream project on EEG or like any kind of device?
Oh, me?
Yeah.
Oh, wow. My dream project is isolating what makes someone a better performer at a task than someone else. Like finding the true nature predictor of that. I believe that, skill development is really important, and that intelligence is better qualified as a collection of skills than it is as a sort of global thing. And that with the right contextual analytical systems, you could take someone that is unfamiliar with a topic, take someone else that is extremely skilled at a topic, and really quantify the differences between them. Finally, you should be able to transfer the skills and the techniques from the experienced person to the novice. And my hope, I don't know. I don't normally talk about these things, but I'm very happy to answer your question. My hope is that we can find a new approach to improving skills, to improving our methods of understanding. And the best analogy, because this is kind of abstract, is before the 1980s, there was no mechanism, nor was there a community of physical fitness. If you wanted to be healthy, I don't know, you take up jogging, or you would go to Nautilus. That's what they used to call it, a gym. And it was this weird thing, if you wore like a tracksuit and you jogged around, people were like, what the heck is this person doing? But with the advent of
running, people would be like, who's following you? Why are you running?
Yeah, exactly. It was so weird, right? In the 70s and the 80s, there was such a cultural aversion to fitness, and it was like a mockery, Oh, look at this person trying to be fit for no reason when they're perfectly fine. But here it is 2020, and we have like Fitbits and heart rate monitors and incredible algorithms. And if you have the, I believe it's the Whoop app that calculates your recovery percentage. So it kind of tells you how much you should do in the gym on a given day. Like it'll tell you, hey, you've been pushing really hard this week, maybe ease up today, your training potential is only 70%. But then another day it'll tell you, hey, you're fully recovered, you're good to go, you're rested, you can go 100% today, have fun. That is amazing to me. You have the 10,000 steps was this fitness revolution. It just gave people one metric. If you walk 10,000 steps, you'll be physically fit. Now, it's not that simple, but it's also not that complicated either. It really is a good proxy metric. If I could find the cognitive equivalent of 10,000 steps and the proof of what it does for you, that's my group.
That's fascinating.
Yeah. So, yeah, and thank you. That's so awesome that you asked me that, and I'm glad to. Yeah, sometimes I'm like it's a little hokey, but I do think that that is how I feel, and that is what I'm passionate about. So, okay, let's take a look at the P300 demo. Let me just find it. Okay, here we go. So if you are familiar with a company named Neurable, not Neurosity, Neurable, Neurable had a combo EEG that they were working on for a while, and it was going to integrate with the HTC Vive. So that's right here. And here is what the device looks like. And if you look at the back of the head, they actually have the electrodes mostly located there for two reasons. One, it's compatible with the VR. But two, this is the visual processing center. So if you were trying to do a visual P300, this is actually it's a unique part of the brain. Most of the brain is non-deterministic, it's non-specific, and it's not really different than anything else. The visual processing center is different. And the reason it's different is because it has almost a bitmap-like structure where there's like a pixel type thing. Anyway, it's easy to map, it's easy to understand, and it's easy to process. It is an anomaly compared to every other brain center for the most part. And so it's a very tempting target. You're like, oh, not only am I dealing with visual information, but I can trust it, right? It's not even like some kind of psychological stuff. I'm reading the processing of their eyes. What could be better? So the issue is just, and I hope I'm not sort of like crushing, or somehow maligning P300s, anything like that. Let me just describe what it is about them for me that doesn't compel. What is the ultimate end? Here's what you can do with it. The idea was to make a VR controller so that you could interact with objects without having to mess with the controller. So in VR, the sticks are horrible. Keeping them in your hand is horrible. Dealing with the experience is horrible. So this is a 1.5 minute demo of an escape room where you're wearing a Vive and you've got this P300 thing on the back of your head. So if you see this little keypad on the right, and I'm going to put this in slow-mo real quick, playback speed 1/4. Okay, let's go. Right. Do you see how it's kind of flashing in sequence? Like the numbers are changing? Sorry, I don't know if you can see my screen here.
Yeah, we can see the screen.
Okay. So do you see how the active number, the number that's in green, is sort of flickering? It's changing. Like now it's an 8. Now it's a 7. Now it's a 9. Now it's a 2. So the basis of this technology is whatever number is lit up when you have a P300 must be the number that you want.
I see.
Okay. So what does that look like applied to other things? So here, the idea is if you want to enter a code like 357, instead of bringing up a keyboard and punching in 357 or fumbling with a controller and hitting 357, when the 3 is selected, your brain is going to go, aha, and then 3 is good to go. When the 5 is selected, your brain's like, yep, that's what I'm looking for, and then that'll be selected. And with the 7, you get the same thing. So now you've done it. Okay. So how about navigation, right? Well, here I'm going to select all the objects. So there's a pyramid and then there's 2 blocks below it. So instead of having like a virtual cursor that allows me to, point, I'm gonna generate one of those P300s when it's on the object that I want. So if I want the orange pyramid, that's good, or the yellow triangle, that's going to generate a response. If I want the blue box, that's going to generate a response. And so now I have the 2 pieces of information that I need. I know what you're looking at, in other words, what object is highlighted, and I know that you're having a P300, which means you want to interact with that object. So the purpose of this technology was to kind of replace controllers and to let you navigate things with your mind. Here's the problem. You got to wait for them to highlight the object. Yeah. There's no other scheme. And so what you save in time by not having to fumble with a controller or to point at something, you lose by waiting for the object that you care about to be selected. Now, if there's only one object, obviously that's fairly straightforward. But when there's multiple, you have to wait. And so this, I think, is sort of like the best implementation of P300 based stuff that I've ever seen. And I can't imagine this being practical in any kind of real world setting.
Yeah, I heard they stopped doing it, they pivoted to something else. But
yes,
I'd ask you something like, does it work though? So it's very cumbersome and like not that useful, but is it accurate? Like, does it get it? Like, is measuring P300 accurate? Is like what this say it does? Like, if can I use it? Like, if I'm okay with the inconvenience?
Yes, absolutely. And EEG Notebooks has, now I don't know if that's fully ready for the Crown. I think they're working on it. So if it's still in progress, I would love to see that. But the just show you real quick. You asked about the Neurable Pivot. They changed to this headphones. Oh, I muted the tab. All right. And I'm going to go ahead and share the screen. So we'll do Neurable N10. So these are EEG headphones that are, I believe, 16 channel, 8 on each ear cup. And they're meant to be worn all day while you're studying, and they're meant to be like normal headphones. So I think this is a much better pivot because you're getting away from this P300 design and you're getting into long-term recordings. And I'm not trying to somehow say that my view of things is correct. I felt like long-term full data collection was the way to go 5 years ago. 5 years later, Neurable is taking that approach, and I don't think that proves that I'm correct. I just think that there is a lot of validity in these long-term qualitative recordings. But to answer your question, do P300s work? Oh, yeah. Visual P300s, auditory P300s. There was a package called Muse LSL that had these experiments built in. It was made by this really incredible neuroscientist named Alexander Barashant, who has contributed a ton of really cool projects to the community. That was picked up then by John Griffiths and Ore and a few of the other folks that join us sometimes here at the Hack Nights, and grew into something called EEG Notebooks. EEG Notebooks, or I'm sorry, John is probably cringing right now. These two things merged, EEG Notebooks and Muse LSL. So the auditory P300 and the oddball P300s carried over, but that package was initially designed for the Muse. And so like a lot of the particulars of how it's tuned and implemented in Python was for the Muse. They have been working on the Crown because Ori has a Crown and is contributing to the project. And yes. So it's if it's been updated for the crown, you would be able to do their experiments right out of the gate. And then basically that the whole point of EEG notebooks is the exact kind of time-locked experiments that you want to do, the P300 and whatever. As a proof of concept that P300 is absolutely valid, is absolutely worth doing, is absolutely worth experimenting with. I just wouldn't build a whole company around it. That's all.
No, I totally see your point. Like,
But I'm
this
not
is,
gonna try to
I
harp
don't
on
know.
it.
I totally see your point. I also said like what I want to measure is my level of focus, and would like I would love to be in a world where I can just move around and like the signal doesn't get messed up, where it's
Right.
able to like denoise that kind of signal and direct like brain health monitoring is possible. So yeah, like this is very cool to demonstrate though. I mean,
Yes,
P300 works.
it does. It does. And one of the simplest experiments is if you do a recording with your eyes open and then do another recording with your eyes closed, see if your alpha changes. I mean, that is one of the there's two other ones that are kind of really well known depending on how you're looking at the raw data. When you blink, it's going to generate an EEG response, right? That's related to the eye movements that I was talking about. So exaggerated blinks are very good as a way of finding them in the data. So you basically just blink really hard, and you do it multiple times. So you can blink 3 times in a row, 5 times in a row, and then you'll see 3 little spikes or 5 little spikes in the data, and that tells you what's going on. The other one is a jaw clench. So you clench your jaw like you're gritting your teeth, and the muscle tremors generate a really strong EEG response. You'll see it kind of jitter around. So your muscles are trembling. There's an electrical discharge from your muscles. There's also like the physical shaking of your skull. Those two things generate a really strong signal. So those are artifacts, but they're artifacts that you can generate on command that really come through. So if you're stepping through the basics of EEG, it's induce an artifact, do some of the P300 experiments, and then quantify some of these longer time series. That's, I think, the progression that people, or sometimes they just stop at the P300s. They don't get into the QEEG. But yeah, like either way, generating noise is a good start. Here, let me see if I can turn this off. Let me see the electric turns red. Okay. So let me see if I can turn this off and get the muse to connect one more time. I'm trying to figure out, oh, okay, I think I unplugged them. Oh, okay. I was messing with the eye tracker, and that. Oh boy. All right. I think I know why we weren't getting muse data. Because this was okay. All right. Oh, some excellent questions. Let's see. Nathan mentions that yes, motor control and is a tricky one. Absolutely. And let's see. See if I can turn off device manager and yep, generic Bluetooth radio. Come on. Disabling the Bluetooth. Ah, this is going to go badly. Okay, so there are ways to look at the raw data. Generating those artifacts will help. And yes, measuring jaw tension, I can absolutely see that. There is something really interesting with responses that are stronger than you would expect. It's a really, really, really good thing that you bring up, Ibrahim, which is like, let's say you're giving someone, I'm going to show you, like a picture of a sailing ship, then I'm going to show you, a picture of whatever, then finally there's like a picture of a war zone. Even if I'm showing you like bad pictures, you should have a similar response to all of them. But if I'm showing you a picture, a series of pictures that are kind of similar in intensity, and suddenly you have like this huge response to one of them, it just tells us that there's something about how your brain is processing that experience that is very different from the others. And so if you have a strong emotional or internal experience that's associated with something, it's going to your brain will experience that instead of the stimuli around it. But that's noticeable because your brain responses are no longer being stimulus driven. They're kind of doing something else. And that's why I think there's been a lot of snake oil around this. And so I totally get people's skepticism. But if you can find a response that seems out of line with the stimulus, it just tells you something is going on there. Okay, so yeah, is it working? No, the Bluetooth, no good. Okay, so yeah, I'll get the Bluetooth going for another time. But in the raw stuff, as you're looking at the signals, do they still have the thing where it just shows you your brainwaves? I don't remember if they have the plot or not. Let's see it.
Does Neurosity Crown give out raw data?
Yes. As in the as a CSV, you can download from the portal, or you can write a tool. You can use something like Lab Recorder, which is a LSL package to record locally. So there's a variety of ways you can get the raw data. You can get it through their portal if you're recording through their portal, or you can use a tool to record locally using one of the streams that they generate. Okay, brainwaves. Yes, we should. Oh, all right, we are online. And I will share the screen. Okay. So this is the brainwaves. Now, a lot of this is filtered for noise, so it's going to look better than it would, but let's try doing a series of blinks. Okay. All that spiking was blinks. I'm going to do a single blink. Do another blink. So I think you can see it, right? Every time there's a blink, there's a series of spikes on every channel. Blink. There we go. Oh, there we go. Two. Yeah, so this is it. This is how blinks look. Now, let's look at jaw clench. See all those tremors? And then you let go. So, all right, we'll do another jaw clench. And let go. So it's these little micro tremors. That's the artifact that you're looking for. These little sawtooth oscillations. That's what tells you you've got that. So, yeah, that's pretty much what.
Oscillations happen in the same way every time you jaw clench, or is it just like some sort of disturbance that I'll see, or like the pattern could be similar?
It's muscle artifacts. There's going to be variations based on like how the electrode gets the signal, but for the most part, if you have a consistent fit and you're doing the motion the same way, you should get similar data. So let's go ahead and do 2 or 3 jaw clenches in a row. All right, so that was one jaw clench. We'll do another one. And one more. We'll wait for this to clear out. Okay, here comes the third jaw clench. So, I mean, there are variations between the channels, but for the most part, I would say that it looks pretty much the same every time.
Do you like the fact that you're talking? Like, does that not cause disturbance? Like, is it?
Oh, it absolutely does. Yes. So this has really heavy filtering applied to it. If it didn't, you would see all kinds of noise every time I talk. But because when you have really good signal quality and the Neurosity has really good electronics and really high quality electrodes, you can do a lot of signal processing stuff to take noise that's present on every channel out. So Neurosity has really nice filtering, and that's why it hides the noise of me talking. But on the back end, yeah, absolutely. It's moving my mouth because it involves moving my jaw is incredibly destructive to the data.
Wow, this is great.
So yeah, in this raw EEG, that P300 that you're looking for is going to involve like a tiny little change in one of these things, you know, like, oh, on channel CP3, you know, instead of a big spike, you know, we get a small spike or vice versa. So that's what those P300s are based off of. This is called raw EEG. It's not transformed through the power spectrum. And then I guess this is symmetry. Oh boy.
Symmetry, like, okay. Does
The
it mean
hemispheres. Does it mean anything? That's a question.
as in, like, is there like a I heard that the left brain, right brain difference in what they do
Yes,
with the hormone.
yes. There's a lot of debate. Some people really feel that there are big differences in the data that are symmetry based. Some people feel any claim about symmetry based stuff is snake oil. I don't try to answer the two. I kind of look at it like, for me, I find a lot of utility in asymmetry, both pupillary and EEG. I think that there's ways to read it that is very useful, but I do agree with not using it as a primary metric. Oh, by the way, yeah, like these, you will have little marks on your skin from the electrodes, but these go away in about 5 minutes, and they're definitely not permanent. So, you know, just if you're going to be like doing a presentation, don't be wearing the crown 2 minutes before. But yeah, other than that, you're probably fine. Or if you do, it'll look like you've got red stuff on your head. But that's also a good way to know that the electrodes are making good contact. Like anywhere you don't see red is not good, because it means that, you know, I wasn't getting friction there. So
Does it get hot?
the back of the unit does, but you don't feel it because it's kind of venting to the back. And so you can feel like the tiniest little warmth at the part that goes to the back of your head, but it's so mild, it doesn't even register. Like, you know, it's warmer, but it doesn't cause any sensation. So they nailed the tolerability of it.
Thank you.
Right. Okay, so basically, once you've got your Neurosity up and running and connected to your account, if you go to console.neurosity.co, that's where all of these, you know, or I'll just give you the link where I just was. That's where all of these are. So once the crown shows up in your app as tied to your account, if you log into that console with the same credentials that you made for the app, you'll be able to see the website of it. And if you're concerned about sending them data, it's in the settings, like the little gear icon, and you want local mode. And but that's really going to cut your focus logging. So I don't know, maybe while you're experimenting, you can do local mode, but if you really want to explore the focus, that I think is going to require sending them, because that's where they do the analysis. That's where they do the data processing. So I guess when you reach the point that you'd be comfortable sending them your data and you want to look at their focus metric, you can take it out of local mode. But if you turn on local mode at first, then you'll be able to just use it within your network.
Okay. Have you tried the music option that they have here, coding with your mood?
I haven't, but I can tell you that music is absolutely legit. And I'm so excited to see Neurosity push this feature to maturity. And I'm not implying that the current feature is not mature, but having a way to measure the beneficial impact of using music is amazing. The Neurosity Crown device is excellent. It's such a good fit. And I mean, right now it's sort of like, take it on my word that it's real. No, the music stuff is absolutely positively real. It's unbelievable how much music changes your brain rhythms and brain power and distribution. More and more through exploring these things, I've discovered that the brain is really rhythmic. And I'm sorry, oscillations, yes, everyone knew this, yes. 20 years late to the party, sure. But rhythms in the brain matter, music matters, what you're doing as you do a task really matters. All these other things really matter. These aren't psychological effects, these are cognitive ones. And what it is, it's kind of like your brain almost plays music, and you can change the way that it plays the music a little bit by playing some actual music. I'm sorry to get too elaborate, but it really is fascinating the way that, different music will affect you. I do believe that those services are very legitimate. Now, how well they align the music to the listener is still a work in progress, because I think they're starting with these general matching algorithms and they're moving to like the more user specific. But when we get to the point that we can look at exactly your focus metric and figure out exactly which songs get your focus into that flow state, and then you put on your focus playlist because you want to do an hour of focus instead of 30 minutes, that's coming in like a year. And I think it's going to be completely real. And that's amazing to me.
It just seems like this is one of those things that they can sell to the general market. And I really like what Neurosity is doing. It's basically selling to software engineers. Like the kind of, he just goes out like Alex and just says that this is just for software engineers. I just thought that he has found a market fit, like with the people will buy it.
I'm so happy for Neurosity. Their market strategy is amazing. The decisions that they've made are amazing, and the quality of the hardware is amazing. From the start, it's been clear that that's a company run by people that understand what they're doing, that have a long-term vision, and that are executing on it. It's been wonderful. And I'm not trying to downplay the accomplishments of other companies, but the speed and the enthusiasm that Neurosity identified the developer segment and put together pretty much the best product on the market for the price point and the capabilities, I think it's a testament to their skills. So that didn't happen by accident. The components that they chose didn't happen by accident. The platform that they built out didn't happen by accident. The SDK didn't happen by accident. The portal didn't happen by accident. The iPhone app didn't happen by accident. The fact that it's Wi-Fi is not an accident. Yeah. So it really shows you a level of intentionality. I'm sorry to sound like their cheerleader, but for me, it's been wonderful to see that on the market, because it just opens up a whole new world of opportunities for me. So why would I not be happy about that? It's wonderful.
I'm 100% sure that if BCI takes off, that this company has like legitimate shot at being an Apple kind of like in this world, because like I can totally see a cult the way that there was a cult around Apple. It's kind of waning, but they can do this because they've so much focused on beautiful design, like, and they're generally nice to their customers. Like with news and all, they have to like it was not easy to get e-data, and Emotive like charges you per month or like something
per minute.
Like that's not very nice.
No, exactly. And so to see a company that gives you all the data, gives you an SDK, and has such an amazing device has been a really, really wonderful thing. And that's why we're so excited. I mean, and this Emotive bit is kind of like the same concept of, what if you could have a $2,000 research device, but you've got, this thing. So you combine these two and you've got $10,000 worth of hardware equivalent in like $1,000, $1,200 footprint for these two devices. That's just wonderful. And then the last piece is, the eye trackers that we were using, the Tobii, these are like their latest. Sorry. Now it's back. I gave up. The Tobii broadcasters, their latest stuff is also good, and they've cut the price significantly and they've upped the performance. And so all at once, these devices that were way too expensive and way too hard to use, bam, like they're good to go. And it just happened so fast, and it's wonderful. It's really wonderful.
Future is coming.
It is. It's hard to believe. We've been talking about it for 20 years, and in the past year, it like happened quick. Like, it's like nothing. Wow. it's quite the shift. So that's great. So I'm really interested. This is going to be awesome. Like I said, please reach out to me on Slack with any, like if you hit any snags with the collection or you're not sure how to process the files or whatever, be super happy to feature it next week. And then I would also love to hear about your experiences if you have a chance to try the metrics. I mean, whatever, a week's not a long time, but we'll take a look at it. And then on my end, we're going to work on adding the plots for the Emotibit so that we can kind of look at those visualizations and comparisons the same way that we do the other ones. But I think the galvanic skin response really being different from the EEG and the pupils is wonderful because it shows you that it's a different measure. It's sort of like psychological state, not cognitive state, which is great. So I don't know. I think this is very, very exciting, and I'm really, really happy that you're starting to experiment with the project, and I would love to hear how it works for you.
Yeah, definitely. I have a long weekend also, so I'm going to get on it. Thanks so much, Alex. I'll do some cooking now.
Wonderful. And thank you for joining us on stage. It was absolutely wonderful having you. Thank you so much for telling us about your project.
Yeah, thank you.
Cool. Okay, well, let's see here. I think for the most part, that's it for things that we can cover for today, unless there's any questions, topics. There's one last one. The Rashi brought up. Oh yeah, the Facebook. I'm sorry, Meta announcement that they are going VR, and they showed off the controller, Meta controller. Oh no, what is this gonna even? Kubernetes plugins? Are you kidding me? All right, Meta controller. Facebook. Oh no. Okay, I can't find the link handy, but I will have it for next week. Facebook has been pushing that wrist sensor control labs thing that tracks your hand in 3D space. The reason for that is you can wear a wristband instead of holding the controller in your hands. VR companies are convinced that this controller thing is like the barrier to VR adoption, aside from the computers and the dedicated space and the not breaking your arms, all those other things that come with VR. But I think Facebook spent $500 million on Control Labs to showcase this feature, and they're definitely very excited about it and making it a prominent part of their platform. So we can take a look at the announcement next week. We'll take a look at that. Also, we'll take a look at some of the latest news and then some more data analysis. Hopefully we can take a look at the crown, and I'll try to have the plots ready so that we can look at the Emotibit. Okay, let me make sure I didn't lose any other questions. Itamar asked, does that correlate with other organs? I don't have a good feel of how the brain rhythms correlate with other things, but it's definitely something I'm interested in exploring in more detail. And that's not meant to be a dismissive answer. That is one of the topics we're looking for, which is what correlates the same way with brain rhythm changes and what doesn't. So what I can tell you is galvanic skin response does not correlate. So that's really interesting. It's like a null result, but it's interesting for us, like, why doesn't it? And what does? So once we have a sense of which sensors do and don't correlate with each other, I think we can start to infer and model why we think that's happening. But yeah, I would suspect that the rhythmic nature of bioprocesses is consistent in many things, but certainly we haven't done the experiments to like really know that for sure. Like what we do know is, hey, this stuff does correlate. And do we have more response in PTSD patients? Yes, I do believe we do. I do believe that one way of detecting PTSD is looking for a response that's unusually strong for what the stimulus would be. What one does with the treatment is also a good question, but can you use it to find something that generates a response that isn't the same response in other people, yeah, you really can. And in PTSD, I mean, that's largely what's happening. Nathan brings up a really good point about motor control and control strategies and BCIs and so on. So let's just take a minute to talk about that. In addition to the P300 experiments, one of the things that people really try to do is create motor imagery mapping. And so if you say to someone, raise your left hand, there's a motor response that happens. If you say to someone, raise your right hand, there's a motor response that happens. If you say to someone, imagine raising your left hand, there's a motor response that happens. And if you say to someone, imagine raising your right hand, there's a motor response that happens. So, classic example of this is someone's in a wheelchair and you want to program the wheelchair. They don't have use of their arms, so they can't control the joystick and they can't move the wheelchair normally. So you want the wheelchair to respond to their commands and you want it to be reliable and you want to use their brain. So those experiments are typically done in the motor cortex, which is going to be like right up here. And you can do single electrode. It's kind of in the same way that there's a visual processing center in the back of your head that does all the visual processing from your eyes. There's a motor cortex in the top of your head that does most of the processing for moving your muscles, moving your limbs, and so on. In the same way that if you're going to be doing a P300 experiment, it makes sense to go to the back of the head because that's where those things are. It also makes sense that if you know you're doing motor cortex and if you know that's what you want, then yeah, top of the head is the place to be. A reflex response would be seen in the motor cortex, but I don't think it's the same. It's the motor cortex is the part of the brain that controls your muscles. Okay. So it's a very easy thing to move your limbs when they're fully functional. And so people have this assumption like, well, imagining stuff. The Neuralink monkey demo was pretty much an example of this. And if anyone hasn't seen it, let's do the Neuralink monkey. Cool. So let's share the screen. Okay. So here's a monkey. Oh, we're playing at quarter speed. And now it's playing this game with a joystick. And when it puts the dot in the orange, in the correct square, it gets a treat of a banana smoothie. That's what this tube is. So, you know, when the monkey gets the ball in the thing, all right, now it's the banana smoothie. So the banana smoothie is pretty good. Monkey likes it, and yeah. So this is the motor cortex working normally. In other words, the it sends a signal to move the hand, and then the hand moves the joystick, and then the joystick moves the cursor, and the cursor gives you the thing. Okay, so now they're going to turn on the Neuralink device, pair it to your phone, and yeah, and what they do is they turn off the joystick. They have a way to mechanically disconnect the joystick and just use the brain implant from Neuralink. So let's see, when do they cut to the yeah, okay, so now the joystick is unplugged, and yeah, so here the monkey was using the joystick, and here the monkey is now, this is the brain, this is the motor cortex. And so the point is if you want to use BCI for this, by the way, you can see how bad it is, right? Like it won't stay in the square, and this monkey has an implant. Let's just look at the fine control here, because I think that's worth looking at. You see, the problem with all these BCIs as they currently are is the accuracy and the fidelity. So in some cases it's working okay, and like the mappings are good, and this is fine, right? But as it starts to get close, like this does not look super great, because the box is moving. We're getting these pink things, and like the cursor kind of like jittered back and forth between the two. You don't see that with the controller. So I think what Nathan brings up very correctly is this is far worse than just using your muscles. And this is the best possible version of it, because in this case, the electrodes, 1,000 of them, are implanted in the monkey's brain. So that's about as close as you can get to the brain, is being directly next to them. And in all the time and in all the capability, and they did one demo for one monkey. I know that sounds like, but actually it's easier to customize a thing for one. It would be harder to make a thing that works for every monkey. Even with all those advantages, look at how it drifts around. Look at how it kind of wobbles back and forth. So this is the big issue with using this in like wheelchairs, is that drift, where the algorithm says, oh, you want to move forward. No, you want to move backward. No, you want to move forward. That's not acceptable. Like you can't have that with something that moves you around, and it misreads what you want to do, so it takes you into traffic at a stoplight or something. I know it's like a worst case scenario, but yeah, the issue is no matter how you do these mappings, it's still a work in progress, and it's nowhere near as clear as the muscles. But yeah, and if you even look at the monkey, you can see the top of the head shaved now. I think that isn't necessarily how they do the implantation, but I do know that they have a little surgical scar. Yeah, right there. You can see the bald spot where it was shaved. So I think those were implanted right there in that motor cortex, and that's what I wanted to show, which is like, okay, here is the monkey, here's the motor cortex, here's what you can do with that. Let me just close that. Cool. So I hope that covers all the questions about motor cortex, or comments, really. It's wonderful. I'm so glad that everyone's contributing, and it's lovely to have this discussion. Let's see, different senses. Okay. And the flow states. All right, well, if anyone has any last minute questions, now is a great time. Otherwise, I think we can declare victory. I can declare that I'm done shocking myself, and we can go ahead and put another successful hack night in the books for now. Yeah, I think I'll have to do it again next week. This thing. So Itamar, if you watch, this is hilarious. Like just the music of this thing about to shock me, like generated this horrible song. I feel uncomfortable handling it. Yeah, it's funny. It's not good. It's not good. that music is oh boy. I don't think they'll be playing that in heaven. All right. So yeah, thank you all for joining us tonight. It was absolutely wonderful chatting with you all, and lovely discussion. We got to look at the crown. We got to look at the Emotivit. We got to look at some data. We got to look at me getting shocked. And I think all in all, those were all good uses of our time. So next week, we're going to dive a little more into the data, hopefully do a few more experiments. We're going to look a little more in depth at the Facebook stuff. And it is so cool to have you all join. Thank you so much.